From the actual data, first of all we are going to do the multiplicative linear decomposition method. So we take the data and we paste it into multiplicative linear sheet, and I'm going to add the t, which is the time period. So 1, 6. And the first column after our actual values, I'm going to add the moving total. For moving total, we start from the third cell, which is equal to T3. We are going to, for example, for the first value, we are going to take the sum of D2 till D5. And the next one will be sum of D3 to D6. And it goes on till the end. But I'm going to take till quarter 3 of 2019, which is equal to T43. So our last value would be sum of D42 till D45. Next, I'm going to calculate the centered moving total. For the centered moving total, it starts from the third cell as well, and we are going to add E4 to E5, which is moving total of T3 plus with moving total T4. And the next one will be moving total T4 plus moving total T5. And continuing till T42. Because if we want to take T43, we don't have value for T44. So these cells will be considered not important, not valid. Next, we are going to calculate the centered moving average. For the centered moving average, we are going to divide the centered moving total by 8. So take the centered moving total value, divide by 8. And this follows till T42 as well, because we don't have the value for T43. Next, we are going to get the unadjusted seasonal indices. For this, we are going to divide the actual value by the centered moving average percentage. So if we fill series this till T43, this is what we will get. Now we have to transfer this unadjusted SI to a table to obtain the adjusted SI. Now I'm going to filter the value to get quarter 1 values only. So as we can see, we don't have quarter 1 value for 2009. So we start from 2010. By doing this for all the values, we can get from the unadjusted SI, we can get a table like this. Now, we are going to get the total value of each quarters equals to sum of this equals to quarter 2 sum of quarter 3 and sum of quarter 4. From this, we are going to get the mean from the total, which is total divided by 4. Total value divided by 4. The total value of quarter 3 divided by 4, and the total value of quarter 4 divided by 4. here we are going to put the sum of mean. As for the adjusted mean, we are going to divide the mean value by the total mean times width 400. So since we need the fixed value of the cell, I'm just going to add the dollar sign. And the same formula applies to each cell. Now we have the adjusted mean value for each quarter. So let's put SI will be 4.71 100.20 102.38 and 102.71. This will be repeated for every quarters. Next, we are going to see the values for deseasonalized. For the first value, we are going to divide the actual value with by the percentage of adjusted seasonal indices. So this value we are going to do till the evaluation part, which is T48. After this seasonalized value, we can see the trend. As for our trend, we are going to use our coefficient and intercept from the regression model. So our coefficient would be negative 41.77, which we are going to times with T1 and then add it with our intercept, which is 31285. And by filling the series till the evaluation part, we get this. Next is y hat value. For the y hat value, we are going to times adjusted SI with our trend. Percentage. So we take our adjusted SI and multiply it with our trend percentage. The Excel formulas, which is ABS, and then in the bracket we add the value. After that, we need to get the error square value, which is e to the power of 2 equals to error power of 2. Last but not least, we are going to get the value of ATE, which is absolute value of E divided by Y percentage. As for the formula, we are going to key in ABS in bracket error value divided by actual value times with 100. From this, we can separate it into two parts, which is evaluation part and out of sample part. So out of sample we have 4 values and in sample we have 44 values. In sample, our MAE is equal to the sum of absolute value error divided by 44, and our MSE is equal to sum of error square divided by 44, and our MAPE is equal to sum of APE divided by 54. These are our MAE, MSE and MAPE value in sample. Out of sample part, our MAE is equal to absolute value of E divided by 4, and our MSE is equal to sum of error square divided by 4, and our MAPE is equal to sum of APE divided by 4. This is the plot graph of our multi-captive linear decomposition method. Next, we are going to look at the additive linear decomposition method part. First of all, we get the values from the actual data, and I'm going to add the p-value, which is period, first of all, for additive linear part, we need to find the moving average. In other words, it's our MA. For the MA, we start from the third cell as well. average of D2 till D5. For the next one, the average of D3 to D6. And this continues to get centered moving average value. We are going to obtain the average of E4 and E5. For the next one, we obtain the average of E5 till E6. And this goes on for every cells. After finding the C and A, we are going to get our unadjusted SI. Our unadjusted SI is equal to actual value minus centered moving average value. And for the adjusted value, we are going to do as same as the multiplicative linear composition model. And where we have to create the same table in our additive linear model. From this, we get our adjusted mean SI value, which is negative 3991.53, 244.19, 1746, 1746.38, and 1507.94. So we are taking this value to put it in this table as adjusted SI. As for our adjusted SI, we can start from the first cell itself. We are going to find the deseasonalized value. For deseasonalized value, we are going to subtract D2 minus H2, our adjusted SI, I2. H2. And this will be till our evaluation part. After that, we are going to go for a trend, and before that we are going to get our plot graph first. So, this is our plot graph, and from the plot graph you can see that our coefficient is negative 49.733 and our intercept is 31465. Using these, we are going to get our trend values, which is negative 49.733 times with x, which is our t value, and plus with 31465. Now we can get our y-hat values. Our y-hat values will be H2 plus with our trend J2. Basically, our estimated value of y is adjusted SI plus with trend. From here, we can calculate the error. For error, as usual, we are going to subtract the estimated value from the actual value. So it is D2 minus K2, K values. So it will be D column minus K column. After we found our error, we need to get the absolute value of the error. So using the Excel formula for absolute values, we get this. After that, we are calculating the error square value. For that, we just select the error value to the power of 2. And last but not least, our APE value. For the APE value, we are going to take the absolute value of error divided by actual value times with 100. Now we can see that in sample we have 44 values until T44, and out of sample we have 4 values. Using this, we can calculate our MAE, MSE, and APE. These are our MAE, MSE, and MAPE values. Multi-captive quadratic model, we just take the values from multi-captive linear model and we are going to add an extra column which is t squared, t to the power of 2. So values will be the part where we calculate the trend, we use our t squared value instead of our t value. So we take the t squared value which is p2. Therefore, we will have a change in the values of trend, y hat, and so on. Therefore, our MAE, MSE, and APE in sample and out of sample will be different. Everything else is just as same as the previous calculation in multi-captive linear. As for the additive quadratic, we do the same thing as we did for the multi-captive quadratic, which we take all the additive linear values paste it, and we insert the t squared values. And same as what we did in multi-captive quadratic, we changed the formula for the trend from t values to the t squared values. Therefore, Our MAE, MSE, and AEE in sample and out of sample values will be different. All the MAE, MSE, and MAPE values for additive linear model, multi-captive linear model, additive quadratic model, and multi-captive quadratic model. From this, we can see that our multi-captive linear model has the least MAE, MSE, and MAPE value. Therefore, we are choosing the multi-captive linear decomposition model for our forecast. For the short-term forecast, we are going to forecast from 2021 till 2025. So we just copy from the multi-captive linear decomposition model that we did before, this one, and we paste it into our real forecast by adding the actual value for 2020. And then, since our adjusted SI will be the same, we paste it till 2025. Now, for the forecast, we are going to calculate the trend and y-hat value. For the trend, since for multi-captive linear model, we don't have to change any extra formulas. We just drag the same formula till 2025 quarter 4. And same goes to our y-hat, which is estimated value. Now we have our forecast values for 2021 till 2025, and this value has been input in here to obtain our graph to show the forecast cycle throughout the years. This is the graph that we obtain from our forecast method. As for the long term, the same thing happens, but we entered our years from 2021 till 2031. As what we did for the short term, we drag the same formula from 2020 quarter 4 till 2031 quarter 4. And this is the plot graph that we obtained from our forecast.